Across much of mainland Alaska, from late March into mid-April, was unusually cold. In the interior Alaska, it was the coldest spring since 1924. In south central, not quite as anomalous, but certainly the coldest spring in decades.
We were curious how that would affect bird migration. We expected the birds would still arrive.
We got here and we waited for the songbirds to show up, and then we realized that the conditions were pretty rough all the way down into Fairbanks, even down to the border. Migrants were just getting stockpiled along Alaska-Canadian border and then into Fairbanks. They could not move forth.
Bird species that come to Alaska for the summer kind of got stopped in their tracks. There just was no open water yet. There hadn't been any melting of lakes, still lots of snow cover.
Tok, Alaska did see a fallout of sparrows and Lapland longspurs this spring, where people woke up after a nighttime snowfall and the ground was just crawling with these little tiny birds. The roadways were the only places that didn't have snow covering them. And so the birds were just getting annihilated by all of the trucks and cars going down the highway. People said there were sparrows in their backyards just cramming their bird feeders, their compost piles, just trying to eat anything that they could find. The store ran out of bird seed right away.
The very cold April and into May in Fairbanks meant that the winter snowpack, which was not unusually high as we came into April, simply didn't melt.
Wacky wasn't a term I used. I think just phenomenal or amazing just to see this many birds over the course of a good 3 or 4 week period.
Folks were skiing on the University of Alaska and Birch Hill ski trails right through the first week of May, and that's highly unusual.
About the last week of April, we went down to start watching for the raptor migration. That's the first wave of birds that come through there. And we saw some pretty good numbers down there, a lot of rough-legged hawks and some eagles. Nothing like you'd expect for this time of year. So we went back the following week in early May and just had our minds blown with the number of swans that we were seeing flying over us. I lost count at 1,000 swans flying overhead, and we drove around the corner of this road, which we call Swan Corner because they do tend to congregate in smaller quantities there every year. And we're absolutely blown away to see thousands and thousands of swans out there in the field and thousands of geese, more white-fronted geese than I've ever seen in my life.
Well, all of mainland Alaska, down through the Northwest Territories and all the way southeast into the upper Midwest, it was quite a cold March into May period. On the other hand, across most of the western United States on up through British Columbia and even into southeast Alaska, temperatures were near to above normal during the springtime. Additionally, over the high Arctic, it also has been a relatively mild spring. Just because it's cold here in Alaska doesn't mean it's cold everywhere.
The raptor numbers were phenomenal too. I swear every 100 feet there was another hawk or an eagle or a falcon in a tree there. We had other birders show up that day. I was texting birders just saying, you have to get down here. I've never seen anything like it. It was just a magical day with the Alaska Range as a backdrop down there and just a million swans, it felt like. It was probably 10,000 birds we estimated in the field that day, but it seemed like a million.
Well, what we had this spring, we had unusually large high pressure which was over the western Bering Sea. Typically we think of the Bering Sea as being home to low pressure systems, but this spring with high pressure anchored over the western Bering Sea, that allowed northerly winds aloft to persist most of the month over mainland Alaska, and that kept it cold.
If you're going long distances, you are reliant on each habitat as you enter and leave it. And if things are changing rapidly,
it's color banded.
which we know they are in certain locations on the planet, particularly in the northern hemisphere and the southern hemisphere.
We're now into the beginning of June, so they're probably a few days delayed, but not too far.
So in many ways, the responses of long-distance migrants are true indicators of the health of the planet. And a lot of people are very aware of this and looking into migratory populations.
Oh, she's flying. She just landed.
So extreme events help to ground us in that there's nothing about climate change or climate variability that says that the weather will become less variable. In fact, there's some evidence that as we move into a warmer climate, that, for instance, some places will cool as high latitudes, the Arctic warms, that places at mid-latitudes, like, say, the northeast United States, may experience more frequent snowstorms and colder weather. Basically, what happens is the cold air that had been over the Arctic gets displaced south. Now, over the very long time scale, centuries, that will change. But in the short term, in the human experience, climate change and climate variability are very complex and can have sometimes what seem to be unintuitive results of a warming climate, like more snowstorms at mid-latitudes.
Let's just use this bare patch over here. Just put a nice I'm part of Team Bird, and we're looking at how global climate change is impacting seasonality in the Arctic. Our lab I'm in is also very interested in hormonal regulation of physiology, so we do a lot of stress physiology, capturing birds and doing a standardized restraint handling procedure to understand their stress response and how they're able to cope with unpredictable events, such as early spring storms.
Get that timer ready.
I got it ready.
Okay. Oh, timer! We're out here at the Tuluk airstrip today, catching birds. We've obviously got an unusual June spring storm.
Like a little thinner. Musical birds.
We're out here to catch the birds and measure their response to that stressful situation. We're taking blood samples.
It's so cold, it's not bleeding as fast.
It's right around freezing, so we're all a little chilled.
So in these birds, when they arrive in the Arctic, they have this really high stress response. It's very active compared to other times of year.
I got 5 minutes on the first bird.
And the thought is that this allows them to respond to spring snowstorms, possible predation attacks, all these sorts of things. And then once they have those nestlings, you see this reduction in the stress response.
1 fat, 1 muscle.
We have this arbitrary scale from 0 to 5, 0 being no fat in a particular area. So we quantify 2 areas up in the furcular region, which is up here, and then the abdominal region, like abdominal fat in humans, basically. So you can blow on the feathers and expose the skin, and you can see how big these fat depots are there. And using the scale, we can say, oh, it's a 2 for furcular fat, 2 for abdominal fat, and that gives us some idea about energy stores.
The muscle also, just before flight, fills up with a lot of lipid. So that's the fuel that drives the contraction for flight. We have a scale now that when we look at a muscle, we can give a measure of its size and also of its fatness.
Arriving birds, when we see them coming in, tend to have larger muscle sizes. Their muscle still has some fat stores in it. They tend to be a little fatter. So we see this kind of arrival biology state.
And also changes colors, goes from this purple color to a light pink color, and most of that is due to deposition of fat within the muscle that causes this color change.
I have it kind of a wine scale. It goes from a color of Merlot to almost like a rosé. And I thought, well, what is going on here? And then we have done some electron microscopy of the tissue itself. And with my colleague Richard Dilleman at University of North Carolina, Wilmington, has found that there are just huge pools of lipid. There is biochemistry behind this. A number of researchers at the University of Western Ontario, Chris Guglielmo, has tracked the molecular changes. We know that the receptors and transporters are there to shovel the lipid into the muscle, and now we have visual evidence that it's there. And once it's there, it's right near where it needs to be because it's taken into the mitochondria, where it provides sufficient energy for muscle contraction.
Maryland caught this bird earlier this season, so it has a U.S. Fish and Wildlife band on it.
What is the band number?
2551-99922, and it's color banded, and the color bands are as the bird would be standing. So in this case, it's white over light pink, and then yellow over aluminum.
Okay.
So we'll just go ahead and take some measurements. We've also been collecting fecal samples so we can get an idea about what they're eating as well. So Ashley, our bug person, is able to go through all these fecal samples, and you can actually get bug parts coming through here, so like fangs and legs will show up, so she can ID roughly if it's a spider or a bug or a beetle or crane fly, these sorts of things.
This one's going bag 8 green.
Migration is a big deal, that it takes a lot of energy and a lot of skill and cognitive ability. So this is a very critical time for birds.
Feather line?
Feather line right here. You picked up a feather, went right to it. Yeah.
GPS already or
We
no?
only watched it for about 10 minutes and she went straight to it. I've DPS'd it and we should back off because I don't want to scare her. And we'll let her settle down, and then once she's gotten a few eggs in there, she'll feel a lot more secure, and then we can do more at the nest.
We're out looking for Lapland longspur nests. It's one of 2 species we follow up here on the tundra. And today we'll be just looking for male and female pairs, trying to find them by song or sight, and then hopefully identifying nest locations. Females are just in the process of nest building, so we're looking for females picking up grass or moss or even feathers, which they'll use to build their nests, and then following them as they carry that to the nest site.
So most of these Laplands come back to the same general area. They may not nest in the same exact location, but they are pretty site faithful. She's got a feather. We just found a Lapland longspur nest, so the female flew over with what looked like a ptarmigan feather, and basically just got a general location on where she came out of. So normally when they visit the nest, they fly away rather quickly, so you just want to focus on where you first see her fly from and then just go investigate that area. In this case, we got lucky and were able to find the nest. So it's actually right here. They line it with ptarmigan feathers so you can kind of see a white flash through the vegetation. So now we're just gonna mark the nest with a tongue depressor and some flagging strips that are gonna be 5 and 10 meters from the nest. Yeah, I did. And we'll GPS this point. All right, let's get out of here. Since the 50s, there's been huge increases in shrub cover on the North Slope. So this is creating new habitat for shrub breeding birds and potentially reducing breeding habitat for open tundra breeding birds. We're using the white-crowned sparrow as our model organism for a shrub nester, and we're using the Lapland longspur as our model organism for our open tundra breeding bird. What we're doing is looking for nests in the Arctic so we can quantify reproductive success for those 2 species.
How many offspring do they fledge a year? How many nests on average get predated?
Some of the newer things that have come out of this is we've been working up at mile point 386, which is the northern limit of the white crown's population, and looking at how their stress response differs from, say, a bird down here on traditional range.
It's too early to say for sure that this is indeed a range expansion, but white crowns are a newcomer to the Arctic. Laplands are Arctic specialists. They had done some pretty detailed bird surveys, I think, in the early 2000s. White crowns, the furthest north they had found them was basically around Happy Valley, milepost 334 on the Dalton Highway. Last year we did another survey and found 2 birds up at 396. Is it colonizer phenotypes, colonizer behavior? Is it because they're being pushed out of southern areas, they're inferior birds that are being pushed out? What is driving this range expansion, really?
And one thing that we found is that they do tend to have a higher stress response on the northern limit of a population's range, and part of that could be due to just harsher climates, or the habitat isn't as good.
It's not that far to Dead Horse. They're not quite shrubs that far, at least not accessible from the road. They're getting there, and if the shrubs get all the way to Dead Horse and expand, they could quite possibly be white crowns up there in the future.
I'm using a reverse leaf blower to vacuum insects off of the tundra. Sort of a jerry-rigged machine. It seems like a lot of entomologists have their own version of it. Mine is just a leaf blower with a insect net inserted in the front of it to catch the bugs as they come off. Oh man, look at all those flies. There's a fungus gnat. He's got big legs and a hunchback. That must be a little wasp, a little parasitic wasp. Some kind of little housefly type thing. Probably a cabbage fly. Bugs are actually really important. Arthropods make up a huge proportion of the biomass, animal biomass of a system. They themselves are part of a larger food web that other animals depend upon.
Birds are migrating up here to take advantage of this huge increase in arthropod biomass.
I've been collecting insects in a variety of ways, using sweep netting or pitfall traps. In the water. So they catch whatever runs around on the ground. So there's a spider, it looks like. Spider and a crane fly. Looks like another little winter crane fly. And now with vacuum sampling, I have a huge reverse leaf blower that I'll be vacuuming insects off of the tundra with. Those are all methods that we're using to track how much bug biomass is available for other animals to eat, such as birds, and also what kind of bug community lives on the tundra, especially in different types of tundra habitats.
When the eggs hatch, the parents are feeding their nestlings almost exclusively on arthropods, and part of that is probably related to the really high growth rates that you see in the nestlings. So they really need a protein-rich food source. That's why they're utilizing those arthropods.
Last year, it was really fun to watch the insect community change over the course of a season. So to see the bumblebees and the spiders get an early start and start flying over the tundra. And then eventually you'd see the hoppers and the other plant-eating insects emerge as the plants matured. And then finally grasshoppers start to come out in full force towards the end of the summer. Insects are a great indicator of what's happening in the environment, not just whether or not they're there, but what types of insects are around can tell you a lot about what's happening to the plant community or what might happen to the animals that consume those insects. week was about the peak of insect biomass on the tundra. I expect that this will be slightly less than last week. But we're catching a lot of different things. Looks like a lot of pollinators and adult sawflies, these wood wasps. A whole bunch of different stuff is in these samples.
Are there more mosquitoes than anything else or not really?
Do you think so?
Yes.
Really? I don't think so. Maybe that's because I see everything else. There's a lot of midges.
Biomass-wise.
Yeah, but abundance-wise, it's probably midges. Yeah, so non-biting midges. Every time that we go out to sample, we set up a random transect just by spinning a pencil in the air. And then we'll walk along that random transect and do 10 samples in that plot. Biomass is kind of a measure of energy in some ways. So we can track not only the movement of nutrients in a system, but just energy in general, energy that starts with the sun and is captured by plants or produced by fungi and eventually taken up by animals, which eat each other.
We know it's one of the first year birds, and we know that we caught it back by the winter lab, so across camp. He has been hanging out here in the last few days. Each bird has a unique radio frequency. Each tag has unique identification. Whenever we want to track one specific individual, we set that frequency on the receiver, and that's how we know which bird signal we are picking up.
What we're doing right now here at Toolik is capturing birds, tracking their changes in some hormone levels and their morphology, the fat and fuel business, and then we are putting on radio tags.
This is the actual technology behind all of it.
We can track their movements here, and what we want to know precisely is when they leave.
So I just pulled one of the loops up on the leg.
So these radios are very small, fitted with a backpack, and after about 40 days they'll fall off, and we won't be able to track them once we leave the Toolik area.
Hold on to that.
We're very restricted to putting on no more than 2 to 3% body weight.
Pull it up there and then check if the harness is on the right spot. Looks like it's sitting as it's supposed to be. Ready?
Yep. I have been up at Toolik for not quite 3 months. I came in the beginning of June, took a slight break in the middle of July, and now I'm back here in the middle to end of August for fall migration. So it's been quite wonderful because I've gotten to see the white-crowned sparrow start building its nest, lay eggs, breed, have its babies, have the babies grow up, fledge the nest, and now I'm getting to see them about to take off for their first flight south for the winter. Bye!
At the end of breeding, family groups break up, and the juveniles, the nestlings, form these large flocks. And the males stay around and tend these large flocks, but these flocks are now moving. So it's not a territorial-based system anymore. It's areas where there's sufficient resources, that is cover and food. And if you look around on the tundra, you'll see lots and lots of berries, all kinds. Blueberries, cranberries, snowberries, crowberries, and when you pick up a bird, their beaks are just full of berry juice.
Ooh, I've got 2!
There's plenty of sustenance for them here, and so maybe the areas where they actually bred are not as rich. So I think what we're working here is that we are catching a lot of juveniles, a lot of previous nestling birds, and able to track them through the various stages in preparation for migration.
So 2 fat, 2 for muscle.
The adult females tend to move through early, and they actually winter further south, so you get a segregation or separation of age and sex classes in these migratory birds. This has been known for a long time in a number of different species.
Is light skin molt, moderate abdominal molt, moderate back molt, light crown.
In the last week, they have changed remarkably in terms of their fat and their muscle, and molt has finished. The Q is really unknown. Temperature, maybe. Photoperiod, probably not. It's changing, but it's probably not the Q. A lot of birds will migrate en masse, so they'll have one individual that will get up and get the whole flock going, and then they'll all go. These birds kind of fly in loose bands. It's almost an individual decision. But it's possible today for people interested in birds, interested in migration, to be able to track these movements. Not only birds, but other migratory species, caribou, monarch butterflies, etc. So in many ways, migratory birds are almost like the canary in the coal mine, that when populations start to decline, they're telling you something not only about the planet as a whole, but individual habitats. And this is dire, but it's also wonderful because we can keep track. We can keep better track now than we ever been able to before.